Alright everyone, so today we're going to be taking a look at this 2017 A1708. This is the 13-inch MacBook Pro with a complaint of no backlight. Now we have some interesting history on this device we're going to go over in a second here, but since it's a 2017 A1708, the very first thing we want to check for is FlexGate. Now I see a lot of confusion between repair techs on the FlexGate issue. FlexGate is only a backlight issue, so if you have lines or stripes on the screen, it is not FlexGate. It is only a backlight related issue. So if the screen is totally dark and you know if it's like dimly lit or something, that's not FlexGate, but if it's totally dark, that can be FlexGate. So FlexGate refers to the backlight flex cable, which runs right here. It is not this one right here. Shops will oftentimes change this out. It is not this cable. It is not this cable. It is not the wider cable. It is the thinner, smaller cable. And to diagnose FlexGate, it's actually really simple. So let's go over to the microscope now. And I just want to demonstrate really briefly how to actually diagnose FlexGate. So what you'll do, you'll find your cable here. Okay, there's two. One side is camera and one side is backlight. Okay, so backlight is going to be on the, if the battery is closest to you, this will be the left side. So with FlexGate, all you have to do is push on this cable a little bit, and what you'll see, you'll see it very clearly. There'll be a crack right across here, right where that little line is. In this case, there is no FlexGate, so it is not our issue. So now let's go over the history of this device a bit. So this has been to a couple other repair companies before it got here ultimately. So it went to a very well-known in the repair community repair shop, not Rossman Repair Group for the record, that incorrectly diagnosed it as a screen issue. Now we've gotten plenty of devices worked on this place in the past, and in 2020 we actually did a video on one of them that got featured on Lewis's YouTube channel. But same company, different day. So they diagnosed it as a screen issue. They sent it back to the repair shop that it came from, who changed the screen 3 times, and it still had no backlight. So the very first thing we're going to want to do, we want to confirm that diagnosis of a new screen. So the first thing, or confirm the diagnosis of a bad screen. So what I am going to do is I am going to just adjust this a little bit where you can see the board. I'm going to go ahead and check our backlight output voltage. That's the very first thing I want to see. I want to see what circuit, or what our circuit is actually outputting to our screen. Typically on this machine, when the screen is bad, we're either going to have 0 volts or 54 volts. There's usually no in-between with screen issues. It's very, very uncommon for there to be an in-between type voltage measurement. Reset my amp meter here. So here is our multimeter, Fluke 287. I'm going to wait for this to boot up a little bit here. It's going to take a minute. So 1 lead on ground as always, and I'm going to put 1 lead on backlight output. You can look at the schematic if you're not sure where to measure. And I have 11.997 volts. That's a little bit weird. So we're going to go over the backlight voltage, the backlight output voltage specifically on the schematic in a second here. But PP bus voltage is 13.047 volts. I want you to remember that 13.047 volts. And in our backlight output, we have 12.773 volts. So let's go to the schematic now. So let's go ahead and open up a schematic for this board. This is an 820-00840. So I'm going to open up the closest comparable for this. Okay, so we have something called right here PPVIN-SOSW LCD backlight FET. Okay, now I'm just going to give you a little cheat. That is PP bus voltage. We'll go over to why that is in a second, but this is going to be PP bus voltage that goes through a current sensing resistor. We have a fuse right here. Okay, everyone here should know what a fuse, if you've been watching this channel, you should know what a fuse does. If there's a short to ground, this will usually blow to protect the rest of the circuit, but usually the backlight driver actually does some magic with current sensing that will even stop this fuse from blowing. And then here we have a resistor, current sensing resistor, right? V-sense, voltage sense, whatever. We don't care too much about that. We have a little MOSFET right here. And the purpose of this MOSFET, what this MOSFET actually does is when it is told to, so when it is enabled here, backlight LCD or backlight EN, this will pass voltage through right here to the coil where the driver can manipulate it and actually boost it to our output voltage, which let's see if it says it here, PPV out SO, V out equals 46 volts, typical 55 volt max. Okay, so it allows voltage to go through. Now when we look at this, we are getting 12 volts on this side, so this is fed by our PP bus, which is 13 volts, and we're only getting 12.73. Now you may think that's not too big of a voltage drop, but that is a voltage drop, and that does kind of raise a red flag to me. So at this point, if this is passing voltage through, we know our backlight, this could either be stuck open or it's being told to open. So we're not sure yet. But in short, it is being told to turn on and pass voltage through, but it is not being boosted to our correct voltage. Kind of an unusual fault on a newer MacBook board. Usually we don't see this type of fault. Anyway, just to alleviate some confusion, I will go ahead and show you where PP bus is derived from right here, just to alleviate that confusion. What's actually funny is in our board view on our fuse, it's actually named PP bus G3 hot on one side, not PP VIN SO LCD backlight. Okay, so we have PP bus on the fuse, which feeds the rest of the circuit. Okay, all clear, PP bus G3 hot. So what I actually want to go ahead and do is I want to rule out that our MOSFET isn't stuck open. So instead of measuring our enable voltage, all I'm going to do is unplug the screen and check our voltage again. If it's 12 volts, then we know the MOSFET is probably bad and stuck open. But if it is not 12 volts, it is being told to turn on when the screen is plugged in. You'll never get backlight voltage with the screen off. Okay, so with the screen off, the CPU will never send that enable signal out to manipulate the backlight driver to enable the MOSFET. So we're going to go ahead and do that now. I am going to switch back over to our overhead cam right here, and I am going to unplug our screen like so. And I'm going to check and see if I get voltage right here. So, 1 volt, that's still the residual charge in the circuit. Let's just power cycle my USB amp meter. That's all normal behavior. Okay, so even with our screen unplugged, we have 12 volts there. That is not good. And based on that fact, we can conclude that we have a stuck open or stuck closed actually, so it's shorting the circuit, backlight, MOSFET, okay? So pretty easy diagnosis to reach. The screen is probably not going to be bad, and let's have a look at the board. So our backlight MOSFET on the board view, you could find it as Q8400, pretty easy to find, but let's just have a look here, okay? Now it looks like this. So when we have a backlight MOSFET that looks like this, we have a pin that looks very abnormal. And another thing I want to do, I want to see if our voltage is actually being pulled down. So another test I could do, since we are getting that 12.73 volts, that shouldn't be the case. We should be, there should not be that big of a voltage drop. It should be fairly consistent with our PP bus voltage. So I'm going to go ahead and test voltage on both sides of this fuse and find out where it's actually dropping down. So right here, I have 13.05, I have 13.05, and out of this resistor, on pin 1 of our MOSFET right here, 13.05, and on our output of our MOSFET here, 12.2. Okay, so it's almost a volt of drop there. That's pretty significant. So this MOSFET should not be passing backlight voltage through at this point because it is not being told to with the screen unplugged. So we can conclude this MOSFET is bad. And if we just looked at the board, we couldn't definitely see that this MOSFET should not be the case. And if we see a MOSFET like this, we should not send the board back to the customer with a diagnosis description of a failed LCD, because it is simply not the case. So we are going to go ahead and remove this. And this does look like liquid damage, so this board will be run through the ultrasonic cleaner. That's off. Want to clean this up with a Q-tip. Looks pretty good. Got to clean up these pads, and there looks to be a lot of debris there, so I'm going to feed some leaded solder in. Little flux in here. Sometimes the flux that's in the solder is just not sufficient. After we have some fresh solder on these pads, now I'm going to wick it. There's still a lot of oxidation on these pads, so the wicking will most likely take care of that, because we're going to be removing that top layer of oxidation. I don't care that I'm ruining the, not ruining, but scraping away the conformal coat on the board. That's fine. After wicking, you can see this looks much better. A little bit more here. But a little bit of oxidation like that's really not a concern. That's good to go. I'm going to put a little bit more solder on these pads, like so. And I'm going to grab a donor, and we are going to put this MOSFET back on, and with any luck, we will have a working board. So this was a pretty straightforward diagnosis. You know, it was a pretty easy fault to solve, and even with just visual inspection, we did not even have to get into any of the circuit diagnostics. We could just, you know, use our eyes and look at this component. It looks corroded, and replace it. That would be, I mean, we could have solved this most likely with just that alone. So there's that. Get a little flux. Just want to touch up these pins just to look a little prettier. And then after ultrasonic cleaning, this component is actually going to get conformal coat as well. One thing that we have started to do here is, especially, this is mostly important on like A17 or A1990s and A2141s, but what we're actually doing now is we are applying this MG Chemicals conformal coat to the work that we perform on the board to protect it from future liquid damage, and on the SSD PMICs on the A1990s and A2141s to prevent failure of those from corrosion and dust, as it's a very, very common problem that causes data loss. So this is a very thin acrylic conformal coating. It does a really good job. We like this better than the UV green stuff. It's, in our testing, has been superior. So after we're done, that component will get conformal coated. That not only helps us see what work we performed prior in case of a warranty return, but it also helps with durability of the component and board. So we'll just put a little drop on that after ultrasonic cleaning, and it'll be good to go. But anyway, now let's do a little test. Now that we have our MOSFET replaced, let's check backlight output voltage again with our screen unplugged, just to see if it will be the correct 0 volts. So let's plug that in, and this amp meter is really not behaving today. I plugged it into a shorted CD3217, and ever since it has not been the same. So there we go. So I should get 0 volts on this. We should have nothing here. So there should be, well, 0.0 something is fine, 0.01 is fine. There's always going to be some small amount of voltage leakage through a piece of silicon, but we have our booting amperage now, and it is staying at 0.1 volts. So that's normal. We should not get 12 volts there. So let's go ahead and put this back in the enclosure, plug in the screen, and hopefully we get a backlit fixed machine. So I'm going to plug this in, just like that. Plug in our, I don't really need much of anything, just the basics. So, and now I'm going to check voltage as well. I would expect to get around 50. That would be what I would prefer, is, 48, 46, 50, whatever. 55, they say peak voltage, but that's really without load voltage. And, if we have no load, we have another problem. But let's watch our voltage. Once it posts, I would expect backlight voltage. There we go, 44.8 volts. That is normal backlight voltage. And if I were to guess, we have a backlit Apple logo on our screen, as we do. I'm going to let this boot into the operating system, and I'm going to block the customer's name when it does pop up. But looks like this one is good to go. Again, nice, easy fault to solve. And this unit does not need a new screen. Just needed a little bit of board work and it is good to go. So, booted into an operating system, we are good to go. Thank you for watching, and I hope this video helps you. If you're another repair store, consider using us. Our diagnostic rates are much better than, not diagnostic rates, but we don't charge for diagnostics, but what we actually diagnose is a lot more accurate than a lot of other repair shops that offer board level repair, so consider giving us a try. That's it for this one, and we'll see you in the next one.